Greetings, welcome all. This is a video lesson on how to use Tracker. Tracker is a video analysis program. We're specifically going to use it today to determine the velocity of a fast-moving tennis ball. Okay, and the motion of that tennis ball has been recorded on a high-speed camera at 120 frames per second. So we're going to slow it down frame by frame, and by knowing the distance in the frame, we'll be able to work out, and knowing the time, of course, because it's 120 frames a second, we'll be able to work out the velocity of the ball. So let's see how this all works. So let's load up a video. So one that I have up here somewhere. Where is it? It's just there before. There it is. Sorry about that. There we go. So, some error may occur in some of the frames. That's quite a large error there, 20%. So it's recommending that we start at frame 1 and end at 292. So anything within those frames is fine. And in fact, we'll be using a very small number of frames. It says to exclude the first frame, frame 0, no problem with that. Okay, so here we go. So let's just play the video as we see it. As you can see, there's an air cannon here. Got a couple of students here. One's holding a meter ruler here, so that's to give us an idea of what distance is. And you can see the tennis ball's just shot out there and has left the frame up here somewhere. Okay, so that all happened very quickly. And excuse me, and even though that was slowed down, it happened in a matter of seconds. So I think between about frame, let's see, 60, just after 60, and then it's out of the picture by about frame 80. So what we can do is move these sliders across, and that allows us to just narrow down the part of the video, narrow the play section of the video down. So let's just bring this back a bit. Maybe bring that back just a few more, maybe frame 61, and this one can be frame, let's get that up here. Yeah, that's fine. So frame 82 is even okay, I think. Yeah, that's fine. So we're just interested in this section of the video. Okay, so you can see that warning message before, it said there may be error in frame 0. We're well away from that. Okay, so in order to do the analysis, we've just got to click some buttons and change some settings. So, and the process is really just starting with this one, then to this one, and that one. And that's it. You just got to remember these 4 buttons here. Okay, so we'll start with this one. This is where we type in our frame rate. So standard video is recorded normally with normal video cameras at 30 frames per second. For us, this is 120 frames per second. Okay, excuse me. Now we need to calibrate distance. So we've got a meter ruler in there. So let's equate the length of this calibration stick to the length of the ruler. So I'll try and get that as close as I can to 1 meter. That looks pretty good. That's probably, let's just bring that down a little bit more. There we go, good. And in here we need to type in 1. So that's 1 meter. So this, we now know what 1 meter is anywhere in this frame. Now obviously the thing about the video here, the shot that we're looking at here, there's depth. So back over here at the house or the fence, that's not going to be a meter, right? But that's okay. The ball will be moving in this section, in this front part of the view, so no problem with that. So I'm just going to put this calibration stick kind of out of the way, okay, so we can get a clear view of the trajectory of the tennis ball. Rightio. Now, we've set the frame rate, we've got our calibration stick in there, ready to go. Now let's put in some axes. So as the ball moves through the frame here, we're going to be tracking its movement, and it will be recorded as X and Y coordinates. Okay, so we obviously need a reference for those X and Y coordinates. So if we set our origin to be here, just at the point where the ball leaves the cannon, now you may well choose to have an origin down here, pretty much where the ball is when it's first ejected. Just bear in mind we won't be able to accurately know the velocity of the ball as it travels through the barrel here, because the first look at the ball is after it exits the barrel. So there is a thing with projectile motion, and that is if we look at the very simple picture of projectile motion, we assume that the ball lands at some distance, horizontal distance away, but in a vertical sense, it lands at the same height from which it was launched, okay? And that just makes the equations work nicely. Now, obviously here, if we have our initial velocity happening at this point here, which is, some distance off the ground, maybe it's half a metre, maybe not even, we're going to be recording the horizontal distance that ball travels, and we'll mark the position where it hits the ground. So it's landing on the ground at some position lower than from where it was originally launched. It's not a big deal, I guess, but just bear that in mind that if we're going to be really precise about what we're doing, then we'd either be considering this as being the launching position here, and mind you, this is not even at ground level, but it's closer to. The other thing we could do is at the other end where it's landing, we could record, where it lands horizontally at some specified or some height that's equal to the height of this. Okay, let's not complicate it for now. So I'm going to put my origin here, and I'm assuming that's pretty much horizontal, or at least level with the ground. It looks okay. So there we go. So we've got our X, Y axes set up. We've got a reference frame for our position now. Okay, so now let's get this back here, get it ready to go. The last thing we need to do here is to create a point mass. So this is essentially, we're going to click it through frame by frame, and we're going to basically make a mark on the screen where the ball is in each frame, and that's the idea of tracking the motion. Okay, so here we go. So clicking through, so we get to frame 63, you can see that the ball is now visible. So to make our first mark, we need to hold the shift key down and then click, and you can see it's automatically moved onto the next frame. Okay, so in a similar way, we'll mark the ball with hitting shift followed by click. Okay, and we just repeat this process over and over. You will notice that at some point very soon we're going to lose sight of that ball. It's quite well camouflaged in against the background. The shadows here are actually helping us to see it, but once it gets into this zone here, it's going to be hard to see. But let's persevere, and I'll try my best to keep an eye on where it is. Now this is going to be a bit of a guess, and now I've lost it. Now what I might do is just take it back a frame or two and just try and watch intently to see where it ends up. Okay, now, alright, I can see it on the 7th frame, and it looks like it's there, so the 6th one might be back here. So I'll just flick it back one, and one more. Okay, and one more. Alright, 4th, 5th, 6th, I'm going to guess it's about here. It's a guess. And 7, and 8, and 9, 10, 11, 12. just remembering that each time we're holding the shift key down and we're clicking on our mouse. And I think, let's get this thing out of the way here. Yeah, there we go. All right, so it's not 100% accurate, but we've got some idea of the trajectory of the ball from one frame to the next. And remember, it's 120 frames per second. So if we look at 12 frames here, that's going to be about 1/10 of a second. And you can see we get to 1/10 of a second after 12 frames. Or close to anyway. Okay, all right, so now let's look at the data that's emerged out of this. Now, what we've got is a table of data here with time against the X and Y positions. Now you'll see the X positions are negatives, and that's because we're moving, along the negative part of the X-axis, so that's not a problem. And the Y would be the height. Okay, so X is the horizontal movement, Y is the vertical movement. Now, we're not really interested in that so much. We're more interested in the velocity. So now to get the velocity, we need to right-click in here and format data columns. Okay, so now I think time is probably a good one to keep, but velocity is probably more what we're after. Now, we can look at velocity, the overall net vector for velocity, but we can also look at velocity in the Y direction and velocity in the X direction. So let's start with that one. Let's see what that does. Didn't do anything. Do it here maybe. That's probably a better place to do it. So we'll keep that as time, but let's make this one, let's just make this velocity, magnitude. There we go. All right. Now that gives us some idea as to what the speeds are. Now it's a bit up and down, as you can see, but the variation is really between, well, the mid-20s and the mid to high 30s. So it's a bit up and down. And remember, there was a few in here that were a bit uncertain. I think the important ones really are the first few. So if we look at the first few, you can see we're well over 30, and so this is 30 meters per second. So, in the past when I've done this, I've had similar variation, but, if we sort of average this out, really, we're looking at around the low 30s, okay? And that at least gives us some idea as to what the speed of that ball is as it's coming out of the air cannon, okay? Now, I guess the idea is that this is just one piece of data, right? So it's just one launch. Probably a good idea to do it for a few launches, because there will be some inconsistency with launching. Particularly, I think the biggest factor is really just the way the release valve is moved. So it can be a bit sticky sometimes, and that can, it makes a difference on how the air pressure is released and then pushed onto the ball. I suppose another factor too, of course, is there's a fair bit of friction in the barrel between the ball and the pipe. It is a tight squeeze to get the ball in there. So, each trial, each go, there's going to be, fluctuations in what's going on. So, so the safe thing to do really is to not just use one piece of video like this, but to use a couple. So I guess that's enough for now. Just to summarise, really, we had to pull our video in here, import the video in. We had to set up the frame rate. We had to calibrate distance. We had to put our axes in, and then we just had to create a point mass. And with shift and click, we traced the ball all the way through until it was out of the picture here. And really, we don't need this much data. We only really need to know what's going on here. But it is nice to get as much as we can. And what we should notice too, of course, is that the speed should reduce as we get up here. The ball, is slowing down the whole time. There's friction, there's gravity working against it. So, excuse me. So we should notice a decrease in the speed as we flick through, each of these frames. Good. Okay. So I think, the conclusion here would be to say, somewhere around 32, 33. There seems to be a lot of dots around there. So that's what I would be going for. Okay. Great. Thank you.